Put your hands together, welcome Caspar Hewett.
Hello. Today I'm going to talk about modelling because that's what I've spent most of my career doing. And no, not that sort of modelling, mathematical modelling. I know I'm not good looking, but here's a model. Just to think about what models are. It's a scale model. Wasn't supposed to have the pen fall out. It's a model of the character of Planet of the Apes. It has some of the features of the original. It looks somewhat like the original. It's a lot smaller. His legs bend, his arms bend, his head turns from side to side. So it actually behaves a little bit like the original, but doesn't have all of its features. It's certainly a lot smaller. If I can get that back in my pocket. Got another model here. Probably a familiar one. It's a paper aeroplane. Now that actually is a very different sort of model. It doesn't look that much like an aeroplane, but it behaves like one. It actually flies, and that's actually quite an effective sort of model. It's the sort of model that engineers like to deal with. I'm a mathematician working in engineering field, so I deal with numbers. The sort of model I deal with, we're actually trying to predict numbers that actually tell us something about a process. So I'm just going to talk about one very, very simple model, because that's all I've got time to do. And that's elastic plastic deformation. What's that, you might ask? Well, there's a rubber band. If I stretch that rubber band, it returns to its original shape. That's probably familiar behaviour. That's what we call elastic deformation. And it will keep returning to its original shape. If I stretch it far enough, and I really, really stretch it, then, yes, you all know what would happen if I went far enough. It would either get my thumb or it would hit the judges, neither of which I'm actually going to demonstrate. But you know how that behaves. That's what we call yielding behaviour once that happens. I might go back in my hair. There's my other prop. It's in there somewhere. There it is, that was holding me up. It's okay, another familiar object. This exhibits both elastic and plastic behaviour. If I just stretch that a little bit, then what you see is it returns to its original shape. However, if I exert more force on that thing, it will yield, but then when I let go, it doesn't return to its original shape. We've actually got a deformed shape that I can look through. So that's what we call, that's the plastic part of the behaviour. Now, the simple model I'm going to talk about is elastic, perfectly plastic behaviour, whereby this part of the behaviour, the elastic bit, we assume is linear. Now, what that means is that if I stretch this that much, it takes a certain amount of force. If I use twice the force, it will stretch twice as far. 3 times the force, it will go 3 times as far. Very, very simple model. When I reach the yield point, where this actually starts stretching like that, I assume that actually I just keep the same force and it will keep changing and deforming. That's elastic, perfectly plastic behaviour.
Thank you very much, Caspar.